Okay, so hello everyone, this is Akshay here, and let us continue with today's GFG Purity Streak. Today's question name is minimum absolute difference in the BST. So हम पास्ट में यार बहुत दिन से BST के क्वेश्चन ही कर रहे हैं, तो ठीक है, आज का भी क्वेश्चन देखते हैं. अगर आपने ऐसा क्वेश्चन देखा है, इट इज़ वेरी सिमिलर टू आवर लास्ट 2 days क्वेश्चंस एंड विल यूज द सेम लॉजिक बट विद द डिफरेंस लिटिल बिट डिफरेंस इन द कोडिंग स्ट्रक्चर. ठीक है, तो पढ़ते क्वेश्चन को. हमारे पास अगेन से एक BST दे रखा है विथ नोड्स n greater than equals to 1. The task is to find the minimum absolute difference between any two nodes. मतलब ऐसे दो नोड जिनका डिफरेंस मिनिमम हो, राइट? जैसे इन दिस केस आई कैन सी दैट 20 एंड 30, अगर इसका डिफरेंस निकालोगे तो 10 आता है. ऐसे और भी कोई ऐसे नोड नहीं है, कोई भी ऐसा पेयर ऑफ नोड नहीं है जिसका डिफरेंस वुड बी लेस देन 10, एंड दैट इज व्हाई 10 इज आवर आंसर, राइट? सो अगेन वी विल यूज द प्रॉपर्टी ऑफ आवर BST, the in order traversal. The in order traversal of BST is nothing but the sorted ascending order, right? अगर आपने BST के बारे में आपको नहीं पता, if you're not aware of the what is the BST, what are the properties of BST, how do we do in order traversal, then definitely we maintain some playlist on our YouTube channel, that is the advanced topics and the uh, some of the other ones, that is the lead code solution preparation and an interview experience, right? So that would be your BST playlist. You can go ahead and watch the standard bunch of questions in the binary search tree. Let us come back to the question again. So what I was saying, so if we do an in order traversal on this tree, so in order traversal क्या मतलब होता है कि root is in the middle and then you first recursively call for left, you go for print the root data and then you call for right, correct? So recursively going for left will be from 50 to 30, 30 to 20. Now it's both left is null, so we'll come to root, so that is 20 would be printed. Similarly 30, then 50, and then 60, 70 and 80, right? So this would be your, let's say, an array or a bunch of elements that is sorted in ascending order. Now if I read the question again, now in this particular array of elements I need to find the minimum absolute difference between any two nodes, right? अब ये क्वेश्चन हो चुका है एक इजी कैटेगरी क्वेश्चन. आप डेफिनेटली बहुत आराम से सोच पाओगे क्या करना है हमें. अगर हमें मिनिमम डिफरेंस चाहिए और एरे भी सॉर्टेड है तो काम बहुत ज़्यादा इजी हो चुका है, राइट? नाउ लेट्स से इफ आई टेक, अच्छा ऐसे बात करते हैं, अगर x माइनस वाई का हमें डिफरेंस सबसे कम चाहिए, राइट? कोई z चाहिए, दैट इज द मिनिमम होना चाहिए, राइट? तो x और y जो हो, x और y जो है ये आपस में जितने क्लोज होंगे उतना अच्छा होगा. लेट्स से 12 and 11. If the differences between increases, if the space between these two numbers increases, definitely z would also be larger. Let's say the x was 20, let's say the x was 80 and y was 20. So definitely there is a very large difference and I cannot get the minimum difference. मतलब कि we need to consider those pair of elements which has the minimum difference in it. तो क्या मैं कह सकता हूँ कि adjacent elements जो होंगे, those are all the potential pairs in which our minimum absolute difference may lie, right? That is for this case 30 minus 20 will be 10, 50 minus 30 would be 20, 60 minus 50 again 10, 70 minus 60 again 10, 80 minus 70 that is again 10, right? So you can clearly see we need to take the minimum of these differences of the adjacent element, that is 10 again. That would be your method 1, that would be our method 1. And what would be the time and space? Since we are doing in order traversal, so time complexity would be O of n for in order, and O of n again for doing this one linear traversal, so O of 2n, but ignoring the constants it would be O of n. Similarly space complexity would be, we will be using this array, right? So O of n plus height of tree, which will be used in the recursive stack space of in order traversal. Ignoring again the lower complexities, it would be O of n. This would be your method 1. Let us see the code in action so that we can move ahead with the another approach or the efficient approach if so possible. So yesterday we did a question of pairs violating the BST property. There we did in order traversal, store everything in an array, right? So we will copy paste the same code in our this minimum absolute difference. Instead there was just one difference, that n was given, so that is why we made an array of size, and here the size is not given, right? That how many nodes are in the tree, that's not given, so that is why we have made an array list here. That's a global variable. So that we can access in the function. So void in order, instead of printing the data we are just saying al.add root.data. अगर आपको in order code समझ में नहीं आया तो binary tree की place again बन चुकी है. Morris traversal, all other traversals are covered in deep depth, so do watch that. At last, once we are done with the in order traversal and storing it in our array list, we had a for loop which is going from 0 to n minus 1, and we are just keeping the track of the minimum differences, and that is it. Let us hit the submit button. While it is submitting, we have already analyzed the time complexity as O of n, but can we see the constraint as well? So constraint is 10 power 5, n belongs to 10 power 5. We have coded in O of n, which is less than 10 power 8. So definitely this code should got submitted, and it has submitted. Okay, should get submitted and it's done. Let us move ahead with the second approach, where we can optimize the space. We can do a time space trade-off, because eventually you have to visit all the elements, right? So can you see that this is the task that we have done as a redundant? We could have skipped this task, right? When we are doing an in-order traversal, and filling the numbers in the array, why not then and there just keep the track of the differences, right? And we'll make, let's say, one pointer more previous, right? And this would be, let's say, our current, right? So I'm at this point and I will store my previous thing, and I will just maintain an answer, and I'll keep the track of minimum current minus previous, that is 10. Similarly, in the next iteration, my current would be here, and I'll update my previous to my previous current data, that is 50 as current and 30 as previous. So similarly, 50 minus 30 will give you 20, and so on and so forth. We'll keep on doing this while maintaining in the in-order traversal, right? So okay, now you must pause this video here, and you already know the in-order traversal code, but instead of just printing the data, you need to do this operation at that point of time, right? So method 2, time complexity would be O of n for doing an in-order traversal, but space complexity would be O of height of tree. That is the recursive stack space. But if you ignore, because sometimes I have seen in some of the interview I assumed taking the recursive stack space and I have given the answer, but they said it is O of 1. So sometimes it is not. If you ignore, let's say, if you ignore that, ignoring the recursive stack space, then I would say O of 1. If not ignored that assumption, then this is height of the tree. Okay. So let us see the second code in action. So we have the standard in order code. We have made two variables, that is the previous and answer, as the global variables. And since we need to track the minimum, so that is why we have initialized answer as integer at max value. Previous को आप कुछ भी कर सकते थे, min max जो मन कर दो, right? That because हम इसमें कुछ track नहीं कर रहे, we are just storing the previous values, right? So in order, instead of printing the data, we are just checking that if previous is not equals to integer and max value, right? Then and there you just keep the track of the minimum. That is, my current data would be nothing but root dot data, and previous is nothing but the previous data which we have stored using this line number 30. Whenever we are iterating for the next recursion, you store that data, right? And that's how we are doing it. Okay. Also, you may have a doubt that why we have written line number 127, right? Direct हम क्यों नहीं लिख देते हैं answer equals to math dot minimum answer comma root dot data minus previous? Yes, like इसलिए क्या यार? Because we want to compute this minimum answer for all the nodes. But जब हम root पे होंगे, let's say when we are at this 50, right? तो इसके लिए previous data कोई है ही नहीं. 50 को किससे minus करोगे? So that is why we have included कि अगर previous जो हमने initialize किया है, that's not equal, then only do the thing. So this if condition will trigger for all the nodes except this root node, that is 50. Great. So again, the time complexity is O of n and points to 10 power 5 less than 10 power 8. So definitely our code should get submitted if we have written syntactically correct. ओके तो ये क्वेश्चन भी हो गया यार. इसी के साथ इस वीडियो को एंड करते हैं. एंड फ्यू लास्ट थिंग्स. सो फ्यू लास्ट थिंग दैट आई हैव मेंटेन सम प्लेलिस्ट यार. तो हमें एडवांस टॉपिक्स में ही प्रॉब्लम होती है सम मोस्ट ऑफ द टाइम्स. बेसिक्स तो फिर भी क्लियर हो जाते हैं कहीं से भी आप पढ़ लो तो that is why I have made a playlist on all of the advanced topics, that is the disjoint set, tries, heap, and specific one lead code solution to preparation, where we have covered 100 questions and which is always asked in the interview. So as of now we have covered 40 questions, but definitely in the coming time I'll be uploading all of the 60 videos as well. So till then, keep learning, keep going. Bye bye and take care guys. If you do like the solution and our way of communication, then do like, share and subscribe, and let us meet again in the next video. Till then, bye bye.